a function f is continuous for all x. All right, that's important to know, and has a local minimum at 1, 8, which must be true. Oh, that's interesting. Oh man, that means, okay, whenever you get a question like this, like which of these are true, you're going to look at every single one and eliminate it. All right, so one of these is true. One of these must be true. And the other ones would then could be false. Okay, so let's look at every single one of them one at a time. Now I don't know what f looks like. I'm going to draw an x and y axis and say at 1, 8, we have a point. Okay, that's all we know. We know that that's a local minimum. It's a local min. Now, okay, let's just read what we got now. Okay, at at 2, the slope is 0. That's what this says because this is f prime. It's saying at 2 the slope is 0. Must that be true? Well, it could be true, but it's not must be true. Now, if they put a 1 right here, you could say, we might be able to say that at 1, the slope is 0. That way it's a local minimum, and then that must be true. So it's definitely not this one. That's a wrong thing. The next one says B, so this one's definitely wrong. B says f prime exists at x equals 2. Okay, let's say, okay, f prime, does f prime have to exist at x equals 2? Well, the local minimum has nothing to do with x equals 2. But the fact that the function is continuous, okay, that might relate to what's happening right there. Okay, must there be a slope at 2 if we are continuous? Technically, no, because here, check this out. At 2, I can go like this. Let's see. Let's go like this, and then, oh, look, we're vertical right there. So it looks like there's no slope that exists right there. F prime, it does not exist here. And look, we're still good. So we have a continuous function here, and we have an f prime that doesn't exist. So boom, that one is not a must be true. Let's look at C. The graph is concave down at x equals 1. Ooh, must that be true? Okay, let's see. Do we have to be concaving down in order for that to be a local minimum? Oh, wait a second. If we're concaving down, that's not a local min. That would be a local max, huh? In fact, let's see, concaving up, that would give us a local min. So if this said up right here, boom, that would have been the right answer. But it's not. C, you are wrong. Let's look at D. Oh, D looks complicated. We're going to have to take this one nice and slow. It says f prime is less than 0 if x is less than 1. So less than 1. F prime is less than 0. So what does that mean? If f prime is less than 0, that would mean f would be decreasing, right? Because that means that the slope would be negative. So this says the slope is negative before 1. Well, yeah, that would be true, right? We have to be decreasing before we get to 1. Okay, that makes sense. And then it says f prime is positive after 0. Oh, no, that's not after 0. After 1. Okay, so after 1, our function f is increasing because f prime is positive. That's what greater than 0 means. This I think is going to be our answer. I'm going to go ahead and circle it, but I still need to check the other one because that makes a lot of sense. That before 1, f prime is negative. After 1, f prime is positive. Yeah, I think D is our answer. Let's look at E and see if we can eliminate that one. This says f prime is positive before 1, which is not true, right? We would have to be decreasing, then increasing in order for us to have a local minimum. So there we go. We don't have to look in the next part where E has been eliminated. So our answer is D for number 23.